Hi class, we're going to take a look at a couple of problems that are using z-scores, and we're basically calling them critical values. Now, for these problems, we do have to take into account the position of the z-score. So for example, they're going to give us that some of the area, which they're going to call alpha here, it's going to be on both tails. You could have it on one tail to the left or on one tail to the right. Please don't worry at the moment about what it's stating there. That's for later topics. Let's actually take a look at an example. Now, in this particular example, they're basically telling us that the critical value happens to be from the normal distribution, and they haven't stated any other value in terms of mu or sigma. So we have to assume that the values of mu are equal to 0 and sigma is equal to 1, so they represent z-scores. If those values are not stated, meaning if these are not changed, then you would assume that they're basically 0 and 1, standard normal, and that's because they're giving us critical values. So we're looking at the standard normal distribution. And in this scenario, this specific critical value has area of 0.10 to the left. So we're looking at this type of scenario. And as I positioned the actual critical value, since it has 0.10 area to the left, I'm just going to say that this value here, it's going to be a z-score. And the area, in this case, let me just try to shade this portion. This portion here is what we're defining as alpha, which is equal to 0.10. Now, I put the code there so we can take a look at it in a minute, but let me just show you how to find this one. And you're basically just going to activate the inverse norm. And the inverse norm works with area to the left. So simply 0.10 area to the left. If you are modifying the mu's and sigma, then you actually add it afterwards with a comma. And in this case, this will be negative 1.28. Once again, to activate it, you go second in distribution and then your inverse norm. So we're looking at negative 1.28. I put in the code there so we could have it as reference. In this case, this is equal to negative 1.28. And let me just write it as a sentence. So in this case, the critical value with alpha is equal to 0.10 to the left is C is equal to negative 1.28. And once again, all critical values are going to be from the standard normal distribution unless they were to modify the parameters. That's actually it for this one. We do have to worry about the position, and keep in mind that for later problems, we're going to have 3 cases. Let's take a look at problem 2, and we have to worry about problem 2 because problem 2, it's also another critical value from the normal distribution. So mu is equal to 0, sigma is equal to 1, and the area is to the right. So technically, let me just add the arrows there. Obviously, these are not to scale, but this is the values of z. And the alpha area, in this case, this portion here, is equal to 0.20. Now, remember that you technically have a distribution. So total area under the curve is equal to 1, or 100% of scores. So that means that in terms of area, this one's going to have 0.80 to the left. The code only works with area to the left, so you would basically run it. And I already have the code there, but let me just type it in so you see it. So this one will be 0.80. your critical value is on the right, so 0.84. If you input 0.20, your critical value is going to be given on the left. By symmetry, it's the same value, but technically it's going to be on the right-hand side. So in this case, 0.84. So our Z value, 0.84. And let me just write it as the critical value with area alpha equal to 0.20 above is C is equal to 0.84. And that's actually it for this one. Once again, remember that the inverse norm requires area to the left. So because you have 20 to the right, that means that you have to have 80 to the left. Let's move on to example 3, and we do have to be very careful on example 3 because it's stated as follows. So they want us to find critical values, and that's because we technically have 2. This will be bell-shaped, and 0.30 is contained on both tails, so that means that alpha divided by 2 is 0.15. And that means that each tail, it's going to have a total area of 0.15. So let me just place them here. This is going to be a Z-score and then another Z-score. And the way that you're running this one, it's going to be the same. So inverse norm of 0.15, which is going to give us negative 1.04 technically if we do to 2 decimals. So on the left, negative 1.04, and on the right, 1.04. And this total amount, it's going to be alpha divided by 2 as 0.15. This area here is alpha divided by 2 and also 0.15, since technically the entire area is 0.30. Okay, so let me rewrite it as the critical values with area of alpha is equal to 0.30 on both tails are C is equal to plus and minus, no, not negative. Since you put the plus and minus, I'm just rewriting it as 1.04. That's actually it for these 3 problems.